Thanks for coming. So today we will be talking about the Gradle version catalog and basically how to migrate to this new shiny thing and what are the steps. And actually I will also show you how easy it is to adapt and not to shy away from the adapting and not to stick with the old build sources and X blocks. So let's begin. My name is Merab Tato Kutalia. I'm an Android GD. And without further ado, let's do some history recap. So we all remember the old Groovy scripts, basically the Stone Age, and let's compare it to and wait what are the pros and cons of this approach. The first thing is that it is very easy to set up. By default, all the Android studios and all the project templates were configured that way until now. The new Android Studio now comes with the default Kotlin DSL, but the configuration, and of course Kotlin DSL and the version catalog, but until now it was all the Groovy. And another good thing is that there are tons of examples how to do a single, simple stuff. And this is also a disadvantage because you have lots of different ways how to achieve a single thing, and it's very confusing. And you can have different signatures in the project of doing the same things. So we don't have the type safety. We have the manual version management. Even though there's the version management dialog in the Android Studio, it doesn't really work. So let's continue that way. And we have these ugly extension X blocks in the root project Gradle without code completion. So this is the example, basically, and we all saw that in our project. Some of us maybe still have this in our project, and I really feel sorry for this because honestly it's terrible. So the next step in this tooling and the scripting was I would define it in the medieval age, was to introduce the build source modules. So basically build source was the initiative, and also with the build source, people tried to mitigate the issues we had previously. First of all, we tried to change the language, of course, with Kotlin. It worked well, but it comes with the drawbacks. So let's first talk about the pros. Pros are of course, the obvious pro is the code completion. Second is the ID support. At least you have the navigation when you do the control click or command B. It's up to you. You can actually see and navigate to the specific dependency, and the type safety because you change the language. But the downside is that it's not very trivial to set up. I saw lots of junior developers struggling with this, how to set up, or just memorizing steps, what were the basic building blocks of this approach, and you're losing cache all the time. So every time you want to update the version, it means that you lose the cache from that module because it was module, and also every time you wanted to update the Android Studio, you were losing the cache as well. So this is the typical build source, how it looked like, and how it looks like in the most repositories. Probably this is one of the most popular approach right now before migrating to the version catalog, and it's sometimes it's very bloated, libraries, versions, all different kind of configurations live there, and from this perspective it's a bit hard to migrate to any new stuff because there's so much knowledge into those files. And here we are. Fast forward to the modern age. We have all the benefits and pros and cons we wanted in the Android development for 8-9 years already. We have the type safety in the build system. We have the standard libraries and the plugins. with the version catalog, we can achieve the one-line implementations. Basically, you can include the whole compose dependencies using one line. You don't lose cache so often. You have the automatic dependency updates, which really work, and you can rely on it blindly and automatically hook up like large repositories and accept lots of pull requests by the bots and blindly merge, of course, passing the CI checks. And the best practices and the easy, how easy it is to set up. But there's one more thing, which is they completely new to that area. It's to publish your dependencies. So it means you can have many projects in your organization. Probably like some agencies have this approach to duplicate, not to white label them, but to duplicate most of the project, but still have some differences, but the dependencies are the same. So you can actually share your dependency list across the project. So you don't need to define it again and again. And it's like very usable feature from the Gradle version catalog. So I believe lots of larger organizations will take advantage of it. So the downside is a bit of downside is the Android Studio support, which was terrible in the previous release, but now it's becoming better. And you see in Android Studio the linter, which now suggests like with a white yellow background that you can update this version to the latest. You can update this dependency to the latest version, and also you have some parts of the navigation. But still, it's missing the convenient ways to edit version catalogs. But it will come. It will come eventually. So this is not really downside. So what is the version catalog? Version catalog is basically this one file with the extension toml. That's it. By default, it's called libversions.toml, but you can call whatever you want. It just this canonical name is convenient because everyone uses this name in the open source. All the bots and everything, like default setup is with this name. So if you stick with that name, it will be good. And the building blocks are like the only 4 of them, and you can use maximum 3. Like 3 are really what you need. The 4th one is like optional. And let's go through what it is. The first one is you need to define the versions. For example, the compose bomb version. You can just define that. Then you need to define the libraries. For example, if you have the AndroidX libraries, just write down those libraries. And the third one is the plugins. Of course, you need plugins. Previously, like the most popular approach was to do everything with a class pass. And most of the libraries now are in a plugin repository, so you can actually use the new DSL and use the plugins from there, but still, you can also use it with a class pass. You just define the plugins there, and the 4th one is the bundles, which is the set of dependencies. So let's go to the building part. I will not be live coding because it will be the tedious job. I'll just show you some building blocks, and we can actually continue this topic outside if you are interested later. So first of all, we need to create the libversions.toml file, which is usually placed in a root Gradle folder, but you can place wherever you want. You just need to point out to the correct directory later. And this is, it looks a bit messy on this screen, but this is what the libversions.toml looks like. And not to be confused, I can highlight some parts for you. So basically, the first one is the versions to define every single version of the dependency you need. Everything in strings, so that's given, so everything should be as a string. And then you have the libraries part, where you just list down all the libraries like you would for any other project. And on down there, you have two different blocks. The first one is the bundles, which you look closely. It's a bit hard to look closely at that screen, but still, it bundles the dependencies under a single name. For example, for the compose, we are bundling compose UI, tooling preview, the activity compose, materials tree, and for the compose test, we have the JUnit, tooling, manifest, so on. So if I write the single line, libs.bundles.compose, I can implement all the dependencies with a single line. It's very convenient. And on the bottom, you have the plugins in a similar fashion. You just have the plugin name and the version reference to the specific version. The different, if you look really closely in examples in the wild, there's the really clear difference between how we describe the libraries. Those are described with a dash, for example, core-ktx, and in the bundles we use with the dot annotation, so compose.ui. So this is things that Gradle version catalog does automatically, so it converts dashes to dots, and it allows us on the implementation side, on the call side, to have some kind of the dependency tree, so you actually can have these breadcrumbs and explicitly say, okay, this is the compose, maybe the compose dot animation dot something like ktx, so it's very convenient. We will see in the next example. So the second thing is that we need to create the Gradle plugin. This is not must thing, but we will need in the future. But you can just, if you don't feel that way, you can just put these same blocks of logic in the normal settings Gradle KTX instead of the building the plugin. But the building the plugin is really easy. Just create a new directory and put the two files there, build KTX, which using the Kotlin DSL, and the repositories where you want to fetch something, and the settings Gradle that points out the correct location of the TOML file. So by default, it's root Gradle, libs versions TOML, but you can change if you want it. So instead of, if you want to use a published catalogs, then you will use not from files but from the actual Maven, and you can reuse the dependencies and everything. It's crazy. It's completely new stuff to the dependency management, at least on Android. And the third thing is that because we created the Gradle, the third thing is that we need to add this plugin as a composite build. So composite build is a bit different, and that's a trick why our cache is retained and not invalidated all the time. We make the changes there. So basically, there's a one line which is doing the trick is to include the build. So our plugin will be included in included build, and the composite part of this build part of the Gradle will take care of our cache. And that's it. Actually, that's it. The only thing is the fourth step is applied to the old Gradles. If you have the Gradle version below 7.4, so you should not have, but if you have, then you need to manually enable this feature because it was beta and you just need this one line. Otherwise, you are good to go. So in 3 steps, you just created your version catalog, and your builds are a bit faster, and you have all the pros from using the lib versions catalog. So that's good. So how we can use it? So on the call side, in the front end. So the first part is the plugins DSL. It's just for convenience here. I'm just using plugins DSL, the alias. In the alias block, you can just reference libs.plugins.android.application. See the dots? This is really helpful. So you can actually have different directory kind of structure. So you can have like logical units. And for example, libs plugins, some specific plugin, and also the group name, so it's convenient, and same applies to the dependencies. For example, libs core KTX or libs.AndroidX and work manager KTX, and so on. And on the last line, you have libs bundles compose. See, with this one line, I just included 3 different dependencies. Cool, right? Yeah, that's the same. What are the limitations? So everything is not for free, and we still have some constraints here. First one is it's not supported in the pre-compiled scripts, so we need to use Type-Unsafe API. So until now, we were using the Gradle generates the stuff for us, like the dot, everything, and we have this 2D autocomplete, and life is wonderful. But if you have to write the custom, like the precompiled script, or if you need to build the convention plugin, which we will see a bit later, then you have to use Type-Unsafe API, which means you have to search it as a string and just use a string. So let's see. This is an example of the Type-Unsafe API. Basically, this is like you can write this function very easily and make it an extension function. So let's go through that function quickly. The first line, what it does is that we need to find by type. This is new type. Version catalogs extensions comes automatically. So we need to find the version catalog with the name libs. If you have like some other name, like libs instead of libs, just put it there, and that's a string. If you miss one character, you're screwed, so sorry. And Gradle, working with Gradle is never easy, so bear with it. And then when you want to declare the dependency, you just have the version catalog dot find dependency, some string of the dependency name, and if it exists, then implement it. So always. That's a limitation. We already mentioned Android Studio, so we are good on that part. So what are the tools that can automate this stuff for us? So tools are the Renovate, which is very, very popular. And most of the repositories right now are using it. Even we use in production for a long time already. It's basically it opens the pull request in for new version upgrades, and you can hook up some rules on top of it, like if CI passes, if there's some things, and automatically merge it. The second rule is the refresh versions, which is also the almost similar tool to get the updates, and also it can migrate to the version catalog, so it scans all your Gradle dependencies and can generate the lib versions .yaml file, which is not great because the end result is not perfect. You still need to manually do lots of stuff, so you have to choose. Either use this tool and fix the dependencies by yourself, or spend 2 hours labor work and manually enter all the dependencies in a single file. It's up to you. I did the latter because I felt that I needed this one. Okay, that's incorrect slide. We can go through the convention plugins. This also will be a bit quick rundown of the convention plugins. This is not that famous like the lib versions. It's a good thing that to have these convention plugins, but it's not a must in that case. But basically convention plugin is a convention over the configuration. Lots of projects benefit from it because you can actually share build logic across the project, across the modules, and if you have heavily modularized application, this is go-to thing. The Uber, the Square, every other large organizations like the Square published the blog post probably even 2 years ago where they were using this. If you check out the Now in Android open source project, you can see also the convention plugins there. So what are the convention plugins? It's a tool and approach to share the build logic, and it's a standard API by Gradle. So it is much more convenient to use this approach because there's a single way of achieving the thing, like achieving the standard stuff instead of searching the Stack Overflow and scripting in Groovy and then have like errors that you cannot handle all the time, and it's terrible. And the conventional plugins are just the plugins that live with your project, and you can actually define the build logic there. So yeah, and also the downside is that if you're using the version catalogs with the conventional plugins, you have to use Type-Unsafe API. Sorry. Okay, let's quickly assemble the simplest convention plugin ever. But hey, it works, and it's basically the fundamental building block for your application. So remember that we created the Gradle plugin for the version catalog? We needed it here, so we don't need to create it again. We'll just modify the build Gradle file. So we'll just add some more lines on the bottom. It's like we added the Android and Kotlin plugins, the dependencies, and we have registered our plugin, the ID and the implementations. That's it. And for the settings, we just added our convention plugin module, like the included. That's it. That's it. Nothing really fancy. And show me the code. Okay. This is the default Gradle plugin thingy. We'll just extend from standard plugin class, and then the apply comes for free. We need to override it, and let's go. So instead of scripting everything in Groovy, why not make it reusable and also testable? So, okay, let's apply Android application plugin and the Kotlin plugin to every module. Okay, applied. Then maybe we need to configure the compile SDK, the default stuff like the target, min SDK, application ID, version code. Usually people had this in a shared Gradle file and included then for every module, and like I've seen lots of terrible pieces of code, so we can fix that. And of course this iconic compile options, source compatibility stuff, and voila. Now we can remove everything, this piece of logic from the modules, and just apply one single module. The Gradle version catalog example, like whatever we call it, that plugin. That's it. So it lives with the rest of the plugins, and that's it. Your build scripts are really small, super slim. You can actually add a lot more logic there on the code part and make it like tuned to your project. For example, the Jacoco part, and also don't forget that you are scripting in Kotlin and not in Groovy. So if you have very specific parts, for example, if you have the Java modules, purely Java modules, the Android modules, you want to apply the code coverage, the Jacoco with the different filters. For example, for a Java project, you need to ignore some other parts. For the Kotlin, you need to ignore the different parts. This piece of code will help you. So, what resources I can use to get more about this stuff? The first one, the go-to resource, is now in Android. This is a very, very good resource of the modern Android development. There's everything, starting from the very fresh Jetpack libraries, ended with the convention plugins and GitHub Actions, everything you need. So get the example, contribute to that repository, and try to play with it. And of course the official documentation from the convention plugin, and also the version update plugin, so you can play with the different toolings. That was the quick rundown about the version catalog and the convention plugin. So if you have any questions, I'm here to answer. Thank you.